Welcome to another episode of Tech Unraveled, where we dive deep into innovative technologies that are shaping our digital landscape. Today, we're exploring something that really pushes the boundaries of graphics rendering: continuous level of detail, or LOD, specifically through a tool called NV Cluster LOD Builder. Now, you might be asking yourself, what exactly is continuous LOD? Well, think of it as a magician's trick for 3D graphics. Instead of changing from one fixed level of detail to another, like snapping your fingers, the continuous LOD allows for a smooth transition between different levels of detail in a mesh. This means that as a camera moves closer to or further away from an object in a scene, the detail adapts seamlessly. Let's break this down a bit. Traditional LOD systems would typically pre-compute several versions of a model, each with a different level of detail. However, with continuous LOD, tiny clusters of triangles can be dynamically adjusted based on their importance in the scene. Imagine you're in a video game, and as you run towards a grand castle, the closer you get, the more details become visible. That's continuous LOD in action, and it's crucial for performance, especially when dealing with complex scenes or large environments. One of the standout features of this NV Cluster LOD Builder is how it manages to do this without eating up too much memory. It uses a strategy called geometry streaming. Have you ever noticed in games how the scenery looks more detailed the closer you get to it? That's because they aren't loading all those high-resolution textures and details all at once. They load only what's needed based on your proximity. Very clever approach, right? The library actually breaks down a mesh, which could have millions of triangles, into smaller manageable chunks or clusters. Each of these clusters can be dynamically swapped in and out based on the camera's position. When those clusters are rendered, they check for detail requirements and ensuring there's no overlap between different detail levels. This is essential because overlapping details can lead to rendering issues, like visual noise that can distract from the game's immersive experience. Now, to get a bit technical, during the building of these LODs, the NV Cluster LOD Builder makes sure to keep track of what's known as a spatial hierarchy. This means it organizes those clusters in a way that's efficient for searching, making it possible to pull up the right level of detail quickly without unnecessary computations. Imagine flipping through an organized binder instead of a chaotic stack of papers when looking for information. And here's a fascinating fact. When rendering, it also considers the viewer's perspective. It analyzes how nearby a cluster is, its size, and if it falls below an angular threshold that determines how it should be rendered. This isn't just a mere guess. It's calculated with mathematical precision to ensure clear visuals without burdening the system. So you might wonder, how do developers actually implement this? Well, the library provides a comprehensive API that allows for the easy integration of continuous LOD into projects. Imagine opening a toolbox and finding everything neatly arranged, making it easy to pick what you need. Simple to set up, but powerful in execution. Before we wrap up, let's reflect on where this technology fits into our broader understanding of graphics. Continuous LOD is not just about making things prettier. It fundamentally enhances the performance of real-time rendering processes. For game developers, this means smoother gameplay and richer worlds. It's a win-win situation for both developers and players. In summary, the NV Cluster LOD Builder is shaping the future of graphics rendering, making it more efficient and visually stunning. Continuous LOD means we can enjoy great detail without sacrificing performance, thus elevating our gaming and virtual experiences to new,